Welcome to Ask and Learn.
We like to use the ratio test to determine whether the series converges or diverges. So this means that we should look at the limit n goes to infinity, absolute value, an plus 1 over an, where an is given by this term here. So let's just go ahead and replace the numerator and denominator. So in this case, we replace n with n plus 1 in our formula here. So that'll give you and then in the denominator, an, which is just this. And I remove the absolute value because all of these terms are positive, so there's no need for it. Now let's just go ahead and take that blue fraction, flip it upside down, and then multiply it to the red fraction. Oops. So now, to make this easier, if you look at the 100 terms here, the corresponding terms, we can write that as 100 to the n. And then the denominator, we can write that as 100 times 100 to the n. And we could cancel those off. That'll give you just a 1 over 100. And now we have to deal with these factorial terms here. So if you see n plus 1 factorial, n factorial, let's go to the definition. This is just the product of all the numbers all the way up to n plus 1 integers in the denominator. And so we see we only cancel the first n terms here, and we're still left with n plus 1. So when we take that limit, we'll have something approaching infinity divided by 100. So this will diverge off to infinity. Now, since we're using the ratio test, we see that we have an expression that's strictly bigger than 1. And that implies that the series diverges. And it diverges by the ratio test.